Anywhere from a quarter to half of the world's food goes to waste every year. In sub-Saharan Africa, for example, certain regions are hit very hard by this.
A great deal of this is due to the lack of refrigeration in the region. This problem is compounded by the fact that in sub-Saharan Africa, 70% of the population lives in rural areas.
Around 20 million people in this region have no access to electricity.
So lack of access to electricity results in massive amount of food being lost.
We are students from the University of Calgary. I'm George in biomedical engineering.
I'm Mitchell in electrical engineering.
I'm Michelle in chemical engineering.
I'm Cissy in mechanical engineering.
And we have come up with a simple and innovative way to tackle this food preservation problem.
Here's an overview of our design.
In looking at coral and termite mounds, we learned that they passively draw in fluids, relying on shape to mold the air into streams. This inspired our funnel design, which draws in the outside air with wind currents, avoiding the need for energy usage.
Now to cool the air. Elephants, vultures, bees, and kangaroos depend on evaporative cooling in order to regulate their body temperature. To mimic this, a pipe brings the air into the evaporative chamber, where it enters a circular network of pipes. The energy from the sun evaporates the water at the bottom and coats the pipes in a thin layer of condensed liquid.
Now comes the wind chill effect. A solar or gravity-powered fan is used to further evaporate the deposited liquid and cools the air even more. This effect is similar to the feeling one gets after stepping out of a pool or the shower on a windy day. Bees and elephants flap their wings and ears to generate a gentle breeze over their skin. In the evaporation chamber, this effect is magnified.
Meerkats, kangaroos, and a number of other animals dig into the first few layers of soil and use the decreased temperature of the earth underneath to cool. The piping and the container have been placed below ground to take advantage of this effect. As the cool air from the system flows into the unit, the earth around it maintains a constant temperature.
In applying life's principles and concepts in biomimicry, we believe that the wind chill food preservation unit can attainably reach the 4.6 degrees Celsius needed to preserve food. So who could use this device? Anyone. The intended demographic is people living in hot environments, but the simple design could be used anywhere in the world. And it allows for minimal instruction, and once initial setup is done, almost no maintenance is required. The unit in itself is not a solution, but it's a tool to improve the food system in the world. Time is saved on a daily basis that can be used for work, for education, or for any other number of things. So imagine applying this technology to a train, to a plane, to a car, or to a ship. Large-scale transportation could be reduced in greenhouse gas emissions and energy expenditure, and reduce the price for the food for everyday people. Thanks. Bye.